Hello folks, my name is Paul and this talk is called Build an iOS app in 45 minutes. Now, it is a real privilege to be asked to speak at the very first Women Who Code Mobile Summit. Thank you so much for inviting me. And when Sierra emailed me to say, hey, do you want to speak at the event? I was like, yeah, brilliant, sign me up, let's do it. But what do you want to hear about? And her reply was, well, how about all the most impactful changes from WWDC22, which is about 6 weeks ago now, maybe 7 weeks. And I could do that. I could talk about all the new SwiftUI changes, all the lock screen stuff. I could talk about WWDC22 for a long, long time. But actually, they're nice changes. I want to have SwiftUI. I want to have lock screen widgets. They're nice to have, but they're not massive new features. On the other hand, new frameworks like Swift Charts or WeatherKit are much more interesting. Now, I know there aren't going to be many weather apps out there or many chart building apps out there, but that's not the point. I consider both these two new frameworks as force multiplying features. The kind of things you can add to your app, no matter what kind of app you make, and they'll get better and better and better. For example, you're making a to-do list app. You might say, hey, that picnic you're planning tomorrow, it's great, good luck with it, but just to let you know, it could rain. Or maybe you could show a little chart of all the items they've checked off their to-do list over the last 24 hours to motivate them. So the ways you can drop these things into any kind of application. And so, today's plan with this comedy picture of me ahead of me is to build an app that will fetch data from WeatherKit. We'll then add some styling to it that looks good on the screen. We'll then display measurements in a nice region-specific way for the user. And then, just as we can, we'll add some charts to this thing. At the end, I'll give some suggestions for ways to take the app further if you want to ship the thing to the App Store. Critically, all this will happen in about 45 minutes, so quite fast, while also trying to explain as much as I possibly can. What could possibly go wrong? Anyway, that's enough chat. Let's get started. Let's go over to Xcode. Now, I've already made a new Xcode project right here targeting iOS. And critically, I've added the capability to have WeatherKit requests. That's required to make WeatherKit calls. Please see this URL over here for how to do that. Okay, with our code, we're going to start small and work our way up quickly. To begin with, how do we know when our app first runs what weather symbol to show? So sunny, rainy, cloudy, lightning or whatever, and also some text to describe it. How do we know? The answer is we don't. We have no weather data yet. We have missing data. Now, we could model this with empty strings. An empty string could mean no data, don't show anything. But it's a great example of where Swift's optionals come in. They represent missing data by default. And so we can say inside our content view here, that's the layout we have on our screen, that there are two new properties we want to have here. We'll say private var, current symbol, is an optional string. So it might be string, could be nothing at all. And private var conditions is an optional string. Now I want to put these two to work in SwiftUI straight away using some new views, things in our UI. One will be an image, which will show our current weather symbol, cloudy, rainy, sunny, and similar. We'll have a text view to show a description of it below, saying rainy or mostly cloudy or who knows what. To be more useful, we want to place the text and the image vertically aligned. So we'll use a VStack, which will let us vertically stack things up. And then around the VStack, we'll make a scroll view. So the whole UI scrolls up and down, adapting nicely to all different kinds of devices. So down here in the body, that's a thing shown on the screen. I'll say there's a scroll view here. Inside there is a VStack, so a vertical stack of views. First will be an image with system name of current symbol. This without the quote marks, sorry. And I'll do font system with a size of 200 and a weight of light. And below that, we'll do text conditions with a font of title. And then around the VStack, we'll say the frame with max width of infinity. Now, this code won't work. That's okay. It's intentional. I'll explain why in a moment and fix it, of course. But first, I want to explain, just to newer folks, what's happening here already. We have the four views I mentioned, images here, text, a VStack and a scroll view. But we also have these method calls on those various views, one here, and one here. And in SwiftUI, we call these things modifiers. They modify the font being used. Or they say, actually, I want this VStack to have a flexible maximum width up to any size. And yes, I have told this image to have a particular font size. Again, that's intentional. This is actually drawing upon Apple's SF symbols icon set, which WeatherKit uses very much. And there's a whole bunch of icons in there for every possible weather type. And they scale according to the font beautifully. Anyway, this code's not working. That's intentional. And it isn't working because we made current symbol and conditions optional, which means we can no longer be sure they have any data. There could be a string in there, could be nothing at all in there, nil or a 0 pointer basically. We made them without data. And they'll remain without data until we finally write some WeatherKit code to actually use them somehow. Now, Swift does not like us using optionals without being sure they are safe to use. If there's nothing in there, they're not safe to use, right? And so we have to unwrap the optional, to look inside the optional, check there's a value there. If there is, take it out and use it somehow. And it looks like this. In our VStack, we could say, if let current symbol, then do this. Or if let conditions, then do this. So we're saying here, if current symbol has a value, give me access to the value and then run this code. And the same thing down here for conditions. And that code will compile, which is great. This is a good thing. But if you go ahead and run the program, you'll just see a big empty screen like that. That's our current program. It's not doing much. Again, that's intentional. If we make the image here and here text down here, that's great. But we haven't got any values for them, that they're still empty. We're saying, if it's got a value, show an image. But it hasn't got a value, it's nil. And so we're going to write our very first piece of WeatherKit code. First, we're going to bring in two new frameworks up here. One is called Core Location, which will give us access to APIs to control location, latitude, longitude, and similar. And the second one is Import WeatherKit, and that gets all the APIs for reading weather data. So now you can go ahead and write some code to fetch our weather data from Core Location. From WeatherKit, sorry. This is done by saying to Core Location, here's latitude and longitude, give me back a CL location. The CL stands for Core Location. So yes, if you are a tautology fan, it means core location. But it's a little thing holding a latitude, longitude that can go off the WeatherKit to work with. Doing this isn't too hard, but it does require three fairly fundamental Swift concepts, and they exist in response to three important questions. First, what happens if the user can't download data because they're offline, or the server's offline, or the network hiccup, or who knows what, right? Second, how can we stop our program from pausing while fetching the weather? Keep in mind we're targeting iPhone here, and so they're on a cell phone connection. Who knows what could happen? And third, how can we perform that download while keeping the rest of our main UI responsive, not freezing up? We'll go ahead and write the function and circle back and see how it answers those questions. Go ahead and add this new method to content view. Func load weather. I'll make a new task that will say let location be a new CL location, latitude 51.51, longitude minus 0.13. Get our weather will be try await weather service dot shared dot weather for that location. Our current symbol is weather dot current weather dot symbol name, and our conditions is weather dot current weather dot description. You can do it. Condition, sorry, there we go. That's the one. Boom. That code still won't compile. There's a theme here, as you can see, with code not working correctly. Before we fix it, I just want to break down what we have so far. This try keyword is our way of acknowledging we're making a network request that might fail. This might go wrong. The user's offline, the server's offline, there's a certificate signing problem. I don't know, something's gone wrong along the way. We've got to handle any errors that throws up. Be ready to handle errors that occur. Next, this await keyword allows this whole function, load weather, to suspend itself while the work takes place. This whole code here can go to sleep while the work's happening. And so other code can run at the same time freely. We're wrapping this work here inside a task, which tells Swift we want this code to run at the same time as our other code, as our main UI code. This is a bit like making a background thread, but in practice, tasks are more efficient. Okay. Those are 3 big differences here, but there's a 4th one. I said, when we say try await, we've got to handle any errors that occur right there. But where is the error handling? Where do the errors go? What's actually happening here is when we make a task like this, it will quietly absorb any errors that occur internally. And after running the task, we can say, hey, did any errors occur? Or we could add our own error handling code inside the task. But in our little sandbox app, we're just brushing them under the carpet. Well, what could possibly go wrong, right? Now, there is, of course, one much more pressing issue at hand. Once again, our code does not compile, which is not great. And we can solve this again by asking a question. How can SwiftUI know it has to update our app's UI when the underlying data changes somehow? How does it know, oh, this has changed from 3 to 4, whatever, update the UI? Now, when you think about any program that's constantly running, many things are fixed, right? You've got hard-coded values, you've got strings you've typed into the code, you've got images you ship with the app, you've got all sorts of things that are completely fixed. But other things change. Other things are dependent on what the user's doing right now. For example, the text they've typed into the screen, or what the highest game score is. Things that will change dynamically as the code runs. In our case, our weather data is also program state, right? We can't store it in the app ahead of time. That'd be silly. We can't predict the future, right? But we want to download it from the internet and use it live in memory. More important, when that program state changes, SwiftUI should reload our layout so it always shows the newest weather information. Now in SwiftUI code, we can accomplish this by adding a special attribute to these 2 properties called @state, like this. @state private var, @state private var. Now Swift calls this a property wrapper because it wraps our optional strings in extra functionality. First, Swift can now store modifying values over time right here, but it also knows that as the code's running, to change the UI when those values change. The last step in our initial setup code here is to get our initial load weather call done. What's the weather right now? So we can say somewhere here is fine. I'll do it on the scroll view, for example. Run my task to load the weather. I'll do .task load weather, like that. Go ahead and start this load weather call when the view is created. And we're done. Or at least done with the very first pass of WeatherKit code. I'll go ahead and press Command R to build and run our code and see what happens. Boom. So you can see it's sunny and it's clear, which is cool. That is the weather for London right now. If you get something else, by all means, change location. We could try, let's try Rome. It's probably sunny there too, I expect. So that's 41.89 and longitude minus 12.48. I'm guessing sunny and clear. Let's find out. Sunny and clear. Let's see, what time is it now? It's so 4:15. So it's early morning in Florida. Orlando's usually a mix of sun and cloud and rain. So let's find out. Let's try Orlando. 28.54 and longitude minus 81.38. Clear, sun. Partly cloudy. There we go. Hooray. Thanks, Orlando. So you can see there's some variation here. So it does correctly get the weather now with a symbol and a description. It's a good start. So that's our first step complete. We have downloaded weather data from WeatherKit and put it onto the screen. Now I know it doesn't look like much. Trust me, it'll get better quickly. Step 2, let's add some styling. Now we're going to pull out and use a bunch more WeatherKit data shortly. But first, I want to pause and do a little bit of UI tweaking so the whole thing looks nicer on the screen. First things first, I want to add a gentle blue gradient behind here and a nice splash of color to our UI. We can do that by saying to our scroll view, I want to give you a background of a linear gradient. And for the colors, I'll say start with blue, going down to a custom color using a hue, saturation, brightness. I'll say hue 0.6, saturation 0.8, and brightness 0.5. Starting at the top and ending at the bottom. And it'll look, all being well, like this. Nice, gentle blue gradient. Now you can see my icon and text, they appear in white. That's because my simulator is running in dark mode right now, so the default color is white text and white images. If you're in light mode, you'll find you have Hey dogs, how you doing? Did you hear white? You did. You want a treat? You do. Okay, come on. Quick shot. Nicely. Nicely. Oh, good dogs. Yeah, good dog. Yeah. So if you're running in light mode, you'll see dark text there. Doesn't look quite so good, particularly with the simulated text up here, status bar text, being dark as well. What we can do is the same thing Apple actually do. They force their UI to run in dark mode the entire time. Oh, hello. Hello. I thought it was a dog coming for another treat. You want a dog treat? No? Come up here. Say hello. You can watch me code for a bit if you want to. Yeah. We can actually force our app to run in dark mode the entire time by adding another modifier just here. We can say, I want a preferred color scheme of .dark. And that means stay in dark mode the entire time. Even if you're on a light mode device, stay in dark mode. Here, give us the dogs. Now, that works well. We can go further. We can say to SwiftUI, hey, these icons are hollow right now, but I think it'd look better if they were filled in, wouldn't you? Yeah, fill in the icons? Okay. So we can say here, I want to switch to a different modifier called symbol variant. And I'll say, give me a filled variant. And these colors, the icons, will be filled in now, drawn full with color instead of being stroked, like that. Ooh. Better, isn't it? Yeah. Even better, we can ask SwiftUI to add some color to these icons. So they have colors built in already, and it knows what they are. So you can say, as well as a variant fill, give me a symbol rendering mode of .multicolor. Yeah. And now, check this out. Yeah? Yeah, okay.
Nice.
Yeah, it's very nice. Now, before we go back and do some more weather stuff here, I want to make one small style change more, which is to make these things look grouped on the screen. So we're going to have this box at the top here with the icon and condition text and so forth. We'll add some more later on. But I want this particular thing here to be a particular box on the screen, separate from the rest of our UI. Now, earlier I said we can place the icon and text in its own little container, and that is this VStack thing right here. That's a container. And that can have its own modifiers. That's why I say you've got a max width frame infinity here, for example. It can have more modifiers. We could say, I want to add some spacing around it or a custom background color and more. And so we'll say down here that this thing has some padding, which means I want spacing around the edges of my view. We can also say I want to have a custom background, and this time rather than having just a gradient, for example, I might say I want to have a solid black color like this, but not full black. Instead, partly transparent black. So a black with opacity of 0.2, for example, which means 20% opacity black like that. We can also change where the box is drawn. I could say I want to have a clip shape here. So not a full square of this box, but instead I want a rounded rectangle with some kind of corner rounding like this of maybe 20 points, for example. And finally, I can say, as well as those other modifiers, add some extra padding. This time, I want to do it only on the horizontal axis. I press Command-I, I'll see how it looks and works. There we go. You like it? I think so, yeah. So what's happening is we're applying padding twice, once here and once here, but at different times, as you can see. We add some padding first, meaning add some spacing around the edges of our views, our picture and text. Then, after the spacing's there, color the whole thing, including the spacing, with our 20% black color. And then round the corners and add extra spacing around that. It's uncolored, so it doesn't quite go edge to edge. I think it looks nice, yeah? Mm-hmm. I think so. Let's go back to our checklist. Okay, so now I've added some styling. You like it?
Yeah.
I think so, yeah. Okay, done. Next up, displaying measurements. You, skedaddle please. Make sure the door's closed. Get the dogs with you, please, yes? Good girl. Now displaying measurements in a nice, region-friendly way. Now that we have some basic styling in place, we can return to WeatherKit. Our single call to weatherservice.shared.weather4location sends back a whole bunch of data for us to display somehow in our program. But it does take a little bit of thinking to get right. For example, temperature. When you have temperature, do we show it in Fahrenheit? Or do we use some kind of unit that most of the world uses, like Celsius, for example? The answer is we don't need to care. WeatherKit tells us this information in an agnostic format called a measurement of unit temperature. And we can display one of these things on the screen and it'll automatically convert to whatever the user wants to see according to their app's settings. To show this off, we could make some new properties up here to store the current temperature, but also high and low for the day. So we might say @state private var current temperature is a measurement of a unit temperature. Like this. Again, optional. And then I'll say @state private var today high temperature is another measurement of unit temperature. And then @state private var today low temperature is another measurement of unit temperature. Like this. So again, I'm using @state and the question mark, the optionals here. So we start with no data when our app launches and fill it in only when our data returns from WeatherKit. This has the advantage that all different parts of our app are independent. If we got, for example, a symbol and current temperature, we can do without conditions and other things just fine. It'll adapt automatically. I would say if I were to build that into a real application, something I ship on the App Store, I'd probably look to break this up somehow into a view model or something similar with less optionality. Anyway, we have 3 new properties to store temperature measurements in an agnostic way. We don't say whether it's Kelvin, Fahrenheit, Celsius, you name it. We don't really care at all. We just say some kind of measurement of temperature. Now, reading this from WeatherKit takes 2 steps because WeatherKit distinguishes between current weather and today's weather. One is what's happening right this second, right now, and what's happening against all today. Different things, right? The first of these is easy because we can actually just add one line of code down here to load weather. We could say our current temperature is weather.currentweather.temperature. Easy enough. The second is a touch trickier because WeatherKit will send us back an array of forecasts for the days ahead. And we only want the first day, like today, right? But what happens if that array comes back empty? What if there were no forecasts for the location we're asking for example? Swift's optionals can help here again because for any one of these kind of sequences of data, we can say, give me the first value here. And it'll be optional because if there's nothing in the array, nothing comes back empty. So we can use if let to read that first value out. If it works, copy it across. We've got a forecast for today. So down here, I'll say if let today is weather.dailyforecast.first. So if we could read the first forecast from the whole days of forecasts going ahead, then our today low temperature is today.low temperature, and today high temperature is today.high temperature. Just copy it across. So we have made some storage for the data. We have copied it across from WeatherKit down here. This can now be displayed on the UI somehow. Now I think the current temperature works best above the partly cloudy, but below the icon, between those 2 things we have already. And so I would say right here between the 2 if-lets, the new if-let, this time for current temperature. I'll say the text is current temperature dot formatted dot font. I'll do system size of 144 in a weight of, let's do bold this time, so nice and strong. So we're now passing in our unit measurement into the text thing here by saying formatted. Convert this thing for me into a nice format for the screen. That's all it means here. And what you'll see here depends on your region settings to your device, by the way. I'm in, I think, US English right now, and so I'll see 89 degrees Fahrenheit in Florida. Lovely and warm, sounds good. And that's nice. That's nice. It looks good. 89F, brilliant. But it's safe to assume the user knows what their region preferences are, what they've told their device to be in the US or the UK or who knows where. They know this. And so that big capital F is kind of redundant. They know it's Fahrenheit, right? And so we can actually ask SwiftUI to adjust the way this thing's displayed. We could say, yes, format it here, but make it formatted as a measurement with a width of narrow. So the smallest way of rendering this particular temperature. So hopefully now I'm going to lose the Fahrenheit symbol. Boom. 89 degrees, partly cloudy. Much more natural. Now when it comes to the high and low temperatures for the day, we can unwrap both these optionals with a single condition, and then apply the same measurement format to get the same result across the board. I think this looks best underneath the words partly cloudy. So I'll say underneath if let conditions, if let today high temperature, comma, let today low temperature. So if I can get both these things unwrapped, now it's more complex. I want to say text is a high of string interpolation, today high temperature, dot formatted, with dot measurement, width dot narrow. And then a low of today low temperature, dot formatted, dot measurement, width dot narrow. And hopefully we should see high and low temperatures. Boom, this is high 93, low 78. Now it works, the code compiles, it runs correctly. I don't know about you, but I find this whole formatted measurement width narrow thing repetitive and annoying. It gets in the way here. And so we can write a very small extension to Apple's measurement type that holds these unit temperatures, saying actually, let's just encapsulate this functionality somewhere else to make our code easier. And so I'm going to say up here on a different file, of course, works well, just outside the structs, the main thing, there's an extension on measurement where it's storing a unit type of unit temperature. We can say there's a new method inside here called narrow formatted, which returns a string. And I'll call self.formatted. I'm calling this on the formatted on the measurement directly. Dot measurement width dot narrow. So the same code we had before, just in one place. And so now when I want to use it, I can say text current temperature dot narrow formatted, or down here dot narrow formatted. It makes a much, much shorter, more concise, easy to read, more reusable, cleaner code, right? I think that's the first section of WeatherKit now done. It looks good. That's nice and finished, I think. I want to make another one showing an hour-by-hour forecast below. It takes the same 3 steps as before. Make a property to store the information you want to read, copy it across from WeatherKit, and then put it into the UI somehow. First property, up here, this will be an array of hour weather. So hourly weather like this. This is WeatherKit's type for storing hour-by-hour weather, like cloud cover, like UV index, like wind speed, and more. So I'll say at state private var hour forecast is an array of hour weather, like this. Now inside our load weather method down here, we're going to copy across the hour forecast into that property, but there's another small twist this time. WeatherKit will send back a whole bunch of data going forwards, but a little bit going backwards as well. So you get some things for upcoming hours and 1 or 2 forecasts that have already passed. To avoid confusion, we're going to filter the old forecasts out, only show things after now. And so in our load weather method here, we can say our forecast property is the weather result dot hourly forecast dot filter. So filter out items to only return those that have a date value beyond now. Now, even with this filtering taking place, we're going to get a whole bunch of many more forecasts than we want in our UI, and that's okay. So we can select how many we want dynamically in our SwiftUI code. Speaking of which, when it comes to the SwiftUI code to display the next section of code here, we'll use the same scroll view we had before, same VStack, same text, same image you've already seen, but we'll make a handful of small changes and one big one. The small one, The scroll view by default, this thing here, scrolls up and down, which is really, really nice. Here though, this particular section will scroll horizontally. So I'll say go left to right rather than up to down. Second, rather than adding padding to the scroll view like we have here, we'll instead have our padding on the thing inside the scroll view. So it'll go edge to edge inside the scroll view. It'll look a lot nicer. Third, I'll give all the symbols a fixed frame. This matters because some shapes like a full sun or a smaller cloud have different sizes. So you can get an uneven UI if you don't fix the frames. I'll have a new view, once called a H stack as well as a V stack. So you've seen this thing's vertical, H stack's horizontal, right? And then critically, each hour of forecast will say, here's a temperature that the forecast is for, but also the date and time that belongs to. Just like measurements of temperatures, times measurement as well. And SwiftUI knows how to display it on the screen. We can customize it saying, yeah, give me the weekday, give me the hour, the day, the month, whatever. We can just say, give me 1 PM or similar, depending on the user's settings locally. Those are all fairly small. The big difference is really at the core of how SwiftUI works internally. When we write our code, scroll view, VStack, yada, 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 Swift actually looks our layout at the type level and says, okay, here goes SwiftUI. Here is a VStack with a text and image, yada, yada, exactly right inside. So SwiftUI knows exactly what's inside our layouts by design. With our hour-by-hour forecasts, though, it's an array of data. And so SwiftUI can't tell ahead of time how many items there'll be, or what they'll contain, or if it will add or change over time. And in fact, it needs to know. It has to know exactly what makes every item on that screen fit together nicely in our UI. Now, SwiftUI gives us a for each view for this purpose. We can say, for each, every one of these things, make some kind of view in there. But SwiftUI still needs to know exactly how to identify every view uniquely. What makes this view different from this view, different from this view. So it can see exactly how it all fits together. Think about it. If you had an array of forecasts of 10 forecasts and you insert an 11th in the middle, it has to know, oh, there's a new one here. It has to be able to say that's different from the ones I had before. So it has to be able to identify its views uniquely. So let's write some code. After the VStack and modifier, so after this bit here, after our first section, I'll say if let hour forecast, we've got an hour forecast here, I'll make a new scroll view going horizontally. Going horizontally. There we go. I'll also do shows indicators to be false. Don't show scroll bars. Then a HStack inside there. And then our for each. The for each of our hour forecast prefix up to 24 with an ID of date. The hour comes in. Then a VStack with text hour.date.formatted. I'll say this thing as just date times fine, in fact, .hour, like that. Boom. Then an image with the system name of hour.symbol name and a frame width of 50, height of 30, and text hour temperature.narrow formatted. And then around it will be the padding. There's a new section here. So I'll apply the same modifiers we had before. I want to have our background color, our clip shape, and our padding as well, like these three here. Just grab them all into here. The padding is inside the scroll view up here, not outside, like that. Now that's mostly straightforward. HStack's horizontal, not vertical. The text has the time being shown somehow. There's a whole bunch of things happening here. The one we really care about is this line of code here, the for each thing. This makes new SwiftUI views from an array, from our hour forecast array here. We don't want the whole array to be shown, only the next 24 hours. I think you get 100 hours by default. So we'll say, give me the first 24 items. This part here, ID \.date, this is how we tell SwiftUI what makes each item in the array different from other items in the array. In our case, it's broken down hour by hour by hour, so the hour is guaranteed to be unique. The date is unique, so we can say that's our unique thing right there. This hour in part, that is the for each going over our array one at a time saying, okay, here you go, here's an hour, what do you want to do? We're saying, well, convert to a VStack instead. That is the second section of our UI done already. Let's press Command R and see how it looks. Dear me, Orlando. Cloudy, 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 cloudy. Nighttime and then sun. Okay. So not a great forecast. This is my time zone, by the way. So you can see I'm in the UK, so 5 o'clock for me. So this is actually showing my times, which is fine. But you can see it gets lovely and sunny at some point, which is great. Anyway, that's 2 sections down. Let's look at our checklist again. So you've seen how displaying measurements is done in SwiftUI. We don't say show Fahrenheit or show Celsius. We just say show some measurements, and SwiftUI takes care of it appropriately with the right thing for the user. Moving on, let's do some charts. What we have so far works. It's nice enough, but we can go one step further. I want to show the chance of rain happening over the next few hours. Now we could do this by just showing a large number on the screen, 70% chance of rain, for example. But in iOS, we can do something much more fun. We can embed dynamic charts right inside our UI. Now, this takes remarkably little code, thanks to another framework called Swift Charts, which you can bring in now by adding a new line to the top, import charts. Now, for this to work, we do not need to copy any new data from WeatherKit. We already have everything we need. And so we can go straight to the SwiftUI code. Down here, we have the if let hour forecast. Inside there is our scroll view, this one here. Boom. I'm going to add directly below that, inside the same if let forecast, our chart code here. So I'll say there's a new VStack with a text saying chart goes here. And then attach to the VStack the same 4 modifiers for our double padding, background, and clip shape, like this. Now, this code is mostly old code, right? You've seen these modifiers before, you've seen VStack before, you've seen text before. It's all obviously cheated slightly. I didn't put the actual chart in there. Fortunately, I only cheated a little bit because it only takes 6 lines of code to turn this into a real meaningful chart, of which 2 are single letter punctuation marks. It's very, very easy. So we'll say inside here, delete the text, as a chart of our hour forecast dot prefix up to 12, ID of date, hour in, as a bar mark with an x dot value of time, hour dot date, unit dot hour, and then a y value of chance of rain with hour dot precipitation chance. And that's all the code it takes to get a good chart up and running, but it packs a lot into a small space. This chart thing down here says to render a chart on the screen from some data, which in our case is the first 12 items from our hour forecast array. Just like before, we're saying you can identify each item uniquely by its date, because the dates are unique. The X and Y values are provided from our data. What is the time on the x-axis, and the y-axis, what's the chance of rain. Notice how I've asked SwiftUI to say for the time, only show the hour component. I don't care about the full date and year it's going to rain. This is an hour by hour forecast. This is a suggestion. Swift Charts is able to say, wait a minute, the hours you're looking at span more than one day. It'd be confusing to only have the hour. It'll adapt show date as well. It's very, very clever. And you also see we have these strings here, time and chance of rain. They are used for voiceover. So whenever someone with voiceover comes into our chart, it'll say time and chance of rain right over in voiceover. It's really, really nice. Anyway, before you run that code, I want to add just 4 modifiers to the chart. They are frame, height 100, foreground style, .cyan, .gradient, .chart y scale here with a domain of 0 through 1, and then chart y axis of .hidden. Now, some of these you can guess, but let's just break it down. First things first, is saying our chart's got an exact height of 100 points, otherwise it'd be squeezed down to hardly any space. It'd be always 100 points high. Second, I've asked Swift Charts to color our bars using a very gentle cyan gradient. The y-scale domain 0 through 1 means here is the full range of our y-axis. It'll go from 0 to 1. Without that, you'll have to read the data to figure out what the range is. And so it might say, oh yes, our highest probability of rain in Rome today is 0.1. It'll look like 1 because it's the highest value. And then we hide the y-axis because showing values like 0.5 or 1 doesn't add much. Is the bar big or small is all we need. Anyway, go ahead and run the app now. That's our chart done. It's that easy. Let's have a look. It's going to rain today. Who knew? Orlando, summertime. Anyway, so you can see our times are across here. It's inserted a date as well because it's spanning July 9th and July 10th. So it's clarifying which date belongs to which. That's really nice. But from here, it is so trivial to go to other chart types. For example, we might say, I want to ditch bar mark and have a point mark. Otherwise, the code's the same. That one little change, and now you'll see little rain points rather than bars. Really nice. Alternative, we could say, I want a line mark. I want to draw a line of rain probability over time. Yeah, that result. So it's still quite low, but it's definitely there. SwiftUI actually draws a straight line between all the various points. You can change that. You could say, actually, I want to have an interpolation between each point using something like catml_rom to get nice smooth splines between all our rain chances. If you wanted to, you could say I want to have points and lines. You could say I want to have my line marks with interpolation, but also a symbol for what our place is here of circle. So draw a circle at every point along the way with a line in between, like that. Now, for rain predictions like this, you can't really see it's going to rain. It's quite a flat chart, even though there is some rain there. I would say the best chart choice is an area chart, because you can literally see almost like the weight of rain that will come over you shortly. They don't support symbols because that would look weird, so we can delete symbol from that. But then change line mark to be an area mark, keeping the same code inside. I think it looks really, really good. There we go. I think that's the clearest way of saying, yeah, it's going to rain around about midnight for me, July 10th or so. Anyway, that's enough futzing around with charts. I think you can see how startlingly simple they are to get started with and modify to get exactly what you want. And with that, we've rendered our charts and our program is finished, at least for now. All that remains is some suggestions to do more. I think the first one is fairly easy. Let the user customize a program with their own location rather than hard coding Orlando or London, or wherever it is. You can use something like MapKit to find cities around the world based on a free text string, get the location and show those instead. And then back it up by Codable to write their stuff out to disk so it remembers their locations over time. In terms of the code, how about getting all that at-state stuff out of our view into a view model where it's more testable, more simple, more isolated, but cleaner across the board is a good idea to do. You could replace those fixed frames with flexible frames using at-scaled metric to scale up and down based on dynamic type. You could, of course, also support landscape mode or iPad or even Mac or who knows what else. Of course, SwiftUI works great in all those things. However, the one thing you must do if you intend to go forward with this to an actual WeatherKit app in the App Store is to add attribution. In your code, you'll see weatherservice.shared.attribution. Read that value. You'll find URLs for dark mode pictures, light mode pictures, and more, crediting Apple Weather for the information. You must do that, otherwise there'd be a massive fight with app review, and no one wants that in their life. Anyway, I hope you enjoyed the talk, you learned something new, you're keen to try out Swift Charts or WeatherKit, and once again, thank you so much for inviting me to speak here. It's a real honor.